Alright, I've reconfigured my device like I said I was in the last video so that I could measure, the basic transconductance curve, of a JFET. So it's the same exact device, and I still got the same probes measuring the current, going into the drain. But the difference is I've detached the source. Source just goes to the ground now, and I got the gate, being driven by the other function generator. So, so I got everything in play here. So I got my WaveGen 2, basically, well, actually, I guess WaveGen 1 is still controlling. I've got it hooked to the gate, basically. Okay, so that it's, and I put, took the liberty to put a, 10K resistor in series with it, just in case I ended up accidentally applying, a positive bias to the gate. But generally, I've got this driven, in a classic way where I'm applying a negative bias to the gate using that, that first WaveGen channel. The second WaveGen channel, I hooked up, by switching my leads there, I hooked it up where it's generating a basically about a 5-volt signal, to power the device. So you got a 5-volt signal going into the drain through this 100 ohm resistor. My probes are across it to measure the current going through the device, and then I, on the gate, have a 100 ohm resistor, in series with it for protection, and then I'm applying my alternate channel to it, plus putting the scope probe so I can measure the voltage out of that channel that we're applying to the gate. Alright, and then of course, the source is going to ground. So, basically here is the result of that. So you can see a, pretty much a classic transconductance curve. So now I don't have this thing quite tweaked well enough. I mean, this is, the waveform I'm sending in, and you can see it's approximately 0 volts, but I don't know, you tell me. I put some offsets into it and so forth, so I got it close to 0 volts, but I'm not sure if it's actually at 0 volts at the peak there. But, so you can see that it's, not quite going down to 0, and it's just kind of flat. I mean, because I originally had it plotted out to 5 volts, but it's kind of flat out there right now. So again, it's going to be tweaked a little bit. As you can see up here, we got the 7 milliamp current. So, at 0 volts. So I guess it's generating 0 volts. I guess it's just not going enough to completely turn the thing off. But I think that's about as far as I could take it. And I could probably try to tweak it, but yeah, I don't think the thing's completely turned off at 2.5 volts. But then again, I don't know, this thing was generating a larger voltage, so for some reason there's an offset, and I haven't figured out why that is. Because this curve, it's flat. Because I had it plotted out over to negative 5 volts originally, and it's just flat, and this is as low as it goes. So it's like the current never quite goes to 0, but I have a feeling there's probably some errors in how I have this set up. This is just an initial quick and dirty test I did. So, but at any rate, it's still, more or less a classic transconductance curve, for this particular device. So, anyway, this is probably about the limit of it. I think this thing can only generate like 10 milliamps. I mean, supposedly it can go up to maybe 50 as it, if you're closer to 0 volts, but, the analog discovery is pretty limited in general in terms of how much current it can generate out of its waveforms, on top of the voltage. I just can't believe these guys didn't want to, just spend the extra money to put a fucking 12 volt supply on the damn thing, then go and use, some sort of a converter, to convert, to get you a negative 12 volt supply out of it. If they didn't want to boast for a plus or minus 24 volt little supply, you know, then they could have, not that one. That's a lotto, but they could have made a lot better of a more useful of a device. And then certainly it's possible, to make a little, op amp, and, so you can increase the voltage range on it and stuff, because scope probes will take it, you could maybe put mass conversion factors into your program or something like that. But anyway, it's just still, it still chaps my ass, they come up with something that's potentially really useful, not just as a learning tool, for students or whatever, but where you could actually use it, as a more serious tool. But this 5 volt range bullshit, it just sucks, and most of these devices are like that. So, anyway, that's just a little gripe. But you know, but yeah, that's a classic little curve there. But that's probably about all you can do with this thing, because there's just not enough channels to do more. So, because ideally you'd want to measure if you want to do a family of curves, because like what I generated in the last video was more or less one of the main curves of a family of curves for this device. But since I got no real way of measuring voltage, since I have to use both of my scope probes to do it, I can't really measure the voltage of the gate, to generate an actual family of curves. But at least I can do this one. So there's something in that's still an important curve. But anyway, cheers.